In this lesson, we're going to specifically focus on the family of linear functions. One of the characteristics of linear functions is that their graphs look like a line. No bends, no curves, just a nice straight, evenly paced line on our graph. One of the special characteristics of a line is the steepness of the line. For example, here we kind of go at this 45-degree slope, going downhill. Here we go uphill, not quite as steeply. And so we can look at how steep those lines are and whether they're going uphill or downhill in order to talk about or describe what's happening with a line. When we talk about this idea of the steepness of a line, we're looking at the vertical change compared to the horizontal change. If there's only a little bit of vertical change and a lot of horizontal change, then it's not very steep. And if there's lots of vertical change, so for example, if we had something like this, where there's a lot of vertical change but not a lot of horizontal change, then this would be really steep. So when we want to talk about this from a mathematical point of view, we can formalize it and call it something called the slope. When we talk about the slope, what we're looking at again is we're looking at a ratio or comparison of how much change we have in the vertical direction compared to the change we have in the horizontal direction. Sometimes a lot of people refer to this as rise over run. And so when we look at the slope, we're looking at how our points change in rise, so up and down, and then how they change in the run direction, left and right, horizontally. So if we go through and figure this out, we can actually do these mathematically. Let's suppose that we start at this point and we want to figure out the slope of this particular line. To do that, we want to find 2 points and talk about the change in how we would travel to get from one to the other. In this particular case, we would go down 1, 2, 3, 4 places. Because we're going down, we'd use a -4 for the vertical change. Then in this case, we're going to go to the right 1, 2, 3, 4, 5 places. And so we could look at something like this as -4/5 as our slope. The -4 correlates with going downhill, and the 5 relates to the change of going over towards the right. In problem number 2, we have a similar concept. If we're starting here and we want to travel to here, first we look at the vertical change. Traveling along the squares, we go up 1, 2, 3, 4 places going up. And since we're going up, we'd call that a +4. And then we're going to run over to the right, and we can count our spaces this way. 1, 2, 3 spaces this direction, 4, 5, 6, and 7. So in this particular case, we'd end up with 4/7. Oh, did I miscount that? 1, 2, 3, 4, 5, 6, 7, 8 spaces to get all the way over to B. Sorry about that. So we'd get 4/8 as our slope, and we can reduce that down to 1/2. Now notice here, in terms of slope, I'm using the variable m, and that's the commonly accepted variable piece that we use when we talk about the slope. We have a formula that we can use. Counting and drawing, I mean, obviously you saw me kind of miscount there a little bit. It can get kind of tricky, and when points don't lie exactly on lines, it can get trickier still. So we do have a formula that we can use to calculate the slope, and that formula looks like this. M equals y2 minus y1 over x2 minus x1. It's a kind of confusing formula the first time you look at it. What we're doing here is we're starting with 2 points that lie on a line. So in this, and 2 points that lie on a line. We use these little subscripts down here, not to do anything from a mathematical perspective, but just to tell the difference if you're talking about the first point or the second point. So this y2 minus y1 means you're going to take the y coordinate from the second point and subtract the x coordinate from the first point. The x2 minus x1 means you're going to take the x coordinate from the second point and subtract the x coordinate from the first point. So that's where our slope formula comes in. It is very important that the vertical change goes on the top and the horizontal change goes on the bottom when you're doing this. So with that in mind, let's take a look at these examples down here below. Notice that here we have the 0.32 and the 0.24. If we're going to do this, this would be considered our x1 and our y1. the x-coordinate from the first point and the y-coordinate from our first point, and this would be considered x2 and y2 for the second point, or the x-coordinate, y-coordinate for my second point. If I put it in the formula here, m equals y2 minus y1 over x2 minus x1, we're just going to plug things in. So y2 was 4 minus y1 was 2. So 4 minus 2, subtracting those y-coordinates. And then we're going to divide by, we're going to subtract the x-coordinates. So 2 minus 3. Then we just want to simplify our fraction. Simplify the top and the bottom, and then reduce whatever is left over if possible. Here we do 4 minus 2 is 2. 2 minus 3 is negative 1. So we can write our slope as 2 over negative 1, or we can simplify that down and say that our slope is negative 2. Over here in this particular example, same idea. We're going to do m equals y2 minus y1 over x2 minus x1 at x1, y1, x2, y2. So let's go through into our subtractions. For y2, we're going to have negative 5 minus the y1 here, which is negative 1. And on the bottom, we're going to do x2 minus x1, so that would be negative 1 minus 4. On the top, don't forget if you're subtracting a negative, that's like adding. So we end up with negative 4, and on the bottom, negative 1 minus 4 is negative 5. Now here we have a negative divided by a negative, so it's best to go ahead and resolve that to be a positive, because negative divided by negative is a positive, and in this case we have a positive slope of 4/5. All right, a few things to keep in mind about the values of the slope and how we can use them when we're solving problems. First of all, notice that this particular line here in example 1 traveled downhill as we read our graph from left to right. This is what we call a decreasing graph, and it happens anytime that it looks downhill. From a slope perspective, this is always going to be a negative slope. So anytime you look at a slope and you come up with a negative number, your graph should be going downhill when you graph those points. Over here, we have an example of an increasing slope. And notice in this particular case that our slope is a positive 1/2. This is an increasing line, and it goes uphill, and these will always have a positive slope. Excellent. So as we continue on here, just positive slope, put that there. All right, so as we go ahead and talk, let's talk a little bit here about our last options. So an increasing slope is always going uphill. A decreasing slope is always going downhill. This is always a slope that's positive. This is always a slope that's negative. Now, sometimes we have a horizontal line. And if you think about a horizontal line, when does that happen when we're talking about the slope? Well, if you pick 2 points on a horizontal line, notice that you don't go up or down at all, so there's no vertical change. So from a fractions perspective, you'd have 0 on the top, and then the distance from left to right would just be however far apart those points are, 1, 2, 12, doesn't really matter. But point being, what we end up with is 0 divided by some number, which always reduces to 0. So if you're ever looking at a slope and you end up with a slope of 0, what you're looking at is an example of a horizontal line or a constant line. Our other type of line that we can talk about here is a vertical line. Now, if we think about a vertical line, notice that we do have a vertical change of some sort, 1, 2, 6, whatever, but then we would divide by the horizontal change, which would be 0. And in this case, notice that the 0 is in the denominator, and that is a huge problem. If you don't believe me, try doing 1 divided by 0 on your calculator. It's going to give you an error. So here we have a slope. In this case, we have what's called an undefined slope. Sometimes people use the term no slope, but people get no and 0 confused with each other. Keep in mind that this vertical line is completely undefined. The slope is undefined. One interesting point relative to what we were talking about in the last unit, we talked about functions. A vertical line is not a function. It's kind of a special case. And if you think about the vertical line test, right, if we were to pass a vertical line here in any of these places, the function's not defined. But if you put the vertical line right here on the line, it's millions of points, so definitely more than one. So that's something that I kind of like to keep in mind, is vertical lines are their own special thing. They're not a function. Their slope is undefined, and that is a special characteristic and property that we have when we're dealing with vertical lines. So if you're ever asked to identify some special properties of a line, as long as you know the slope, if it's positive, negative, 0, or undefined, you would be able to tell some interesting characteristics about what the line itself would look like, and that being able to recognize these relationships is very helpful as you're solving different types of problems.